Hello, welcome back to my recorded classes. This recorded class, we are discussing the topic, section number 5.4, expected value and variance. This is your topic from module number 5, discrete probability, correct? So let's start the content here. So let's start with one example. Okay, so first point we are discussing what is the meaning of random variable. Okay, random variable. So we will define what is the meaning of random variable here. I will explain first. So before going to that example, you can see what is the meaning of random variable. Random variable means usually we are representing capital letters, capital X, Y, Z like this. Okay, so a random variable X is a real valued function whose domain is the sample space of the random experiment. That means random variable is a function X from S to R. S means, as I told you, it is sample space. S means sample space, and R means set of all real numbers, correct? Real numbers. Real numbers means all the numbers 1, 2, 3, 4, 1.1, any numbers, correct? So set of all real numbers, sample space to real numbers. The sample space we are calling the domain of the function. All of you remember in module 3 we are studied the function, about the function. So domain of the function, and this is the codomain, correct? Codomain of the function. So a random variable, that means X, capital letters we are using. X means this is the random variable. RV I am representing. RV means random variable. It is a function from real valued function from the domain sample space. Okay, sample space. For example, you can see one example here. In the experiment of tossing a coin 2 times. Okay, we are just tossing a coin 2 times. That means first toss either head will get or tail will come, correct? Now second toss also same. If first toss is head, second toss either head will come or tail will come. Same way, first toss if you go to tail, second toss may be either head or tail. This is the tree diagram, correct? So what are the options when we are tossing a coin 2 times? Either head, correct? The first outcome is head. The second one head tail, correct? And the third one tail head, and fourth one tail. So there are 4 outcomes we are getting: head tail head, and tail. That means number of elements of the sample space equal to 4 here, correct? This is the sample space, so number of elements of the sample space equal to 4 we are getting. Now let's discuss about what is the meaning of random variable defined in this random experiment. For example, X denotes the number of heads obtained. Number of heads. When we are tossing coin 2 times, how many times head came? Okay, number of heads obtained in each outcome. For example, X of head. The first outcome is head, correct? So X of head means the random variable representing the outcome head, correct? So how many heads are there? 1, 2. There are 2 heads. So what is the answer actually? 2. Now same way the second outcome, the X of capital X of head tail, the second outcome. So how many heads are there? Only 1 head. So X of head tail means equal to 1. Now the third one, tail head. So X of tail head. X means the random variable representing the outcome tail head means only 1 time head, so equal to 1, because random variable is defined number of heads only we are taking, correct? Now the same way the last outcome tail, X of tail means there is no head here, correct? There is no head, that means 0, equal to 0. So what are the numbers we are getting for the random variable X? X takes values, either we are getting 0, okay, or we are getting 1 here and here 2, both are same, 1, and 2 here, or 2. So what are the values of the random variable X? Either 0 or 1 and 2, correct? 0, 1 and 2. So we can see this picture. Okay, that function I am represented here, one arrow diagram. So domain of the function, this is the first set we are calling the domain of the function. This is we are calling codomain of the function. This is set of all real numbers, codomain. Now see what are the numbers coming here for random variable. For example, first outcome head, we got number of the number of the head means it is equal to 2, correct? So we are just drawing an arrow diagram representing that function x random variable number of heads, and head tile we are getting 1, tile head we are getting 1, and tile we are getting 0 here, correct? So this is the representation, this is the random variable x. I hope you understood that one, what is the meaning random variable, correct? So now you can see this definition, you must be clear now. X is a random variable from S to R. That means random variable means it is a real valued function whose domain is a sample space. Domain sample space to a real number, correct? Here see domain is sample space we are written, but the codomain set of all real numbers. So here you define the range of that function 0, 1 and 2. That means x takes the values 0, 1 and 2. Hope you understood what is the meaning of random variable. Now there is some remark here. More than one random variable, we can define in one sample space. Okay, we can define more than one random variable in a sample space, and random variables are usually denoted by capital letters like x, y, z, like that. Now let us see the first point. More than one random variable can be defined on a sample space, on one sample space, correct? For example, the same example whatever we discussed here, the experiment of tossing a coin 2 times, correct? The experiment of tossing a coin 2 times, just now we discussed it. In that experiment, see, first we defined a random variable x denote the number of heads, correct? So I explained that one. X of head means 2, x of head tile means 1, x of tile head is 1, and x of tile equal to 0. And the arrow diagram you can see on this side, this is the arrow diagram representing that random experiment and random variable, correct? Now see, for example, the same sample space, this sample space, okay, head tile head and tile, same sample space, I am defining another random variable y, capital Y, okay, using capital letters always. Y denotes the number of tiles. I am defining like this, number of tiles obtained. So what are the values of that random variable we are getting? For example, y of head, correct? How many tiles are there? Tile 0, correct? Here 0, nothing is there, there is no tile, so 0 we are getting. Y of head tile, how many tile will be there? Only 1, so 1 we are getting. Y of tile head, how many tiles are there? 1, so 1 answer. Y of tile 2 tiles are there, so we can get it equal to 2. So here also the random variable x, what are the values of the random variable x? Either 0 will be there, or 1 will be there, or 2 will be there. 1 coming 2 times, correct? And 2 1 time, and 0 1 times coming. So the random variable takes the values 0, 1 and 2 here in this same sample space. This is the second random variable. That is the meaning of here we tell the remark, more than one random variable can be defined on one sample space. Now see another example here, the third random variable here defined the another random variable in the same sample space, whatever we discussed in that example, correct? See, for example, the random variable z denote the number of heads minus number of tiles. Okay, how many heads minus how many tiles? Number of heads minus number of tiles. For example, z of head, z of head, how many heads are here? 2 heads, correct? How many tiles are here? 0 tiles. So 2 minus 0, number of heads minus number of tiles. So what answer we will get? Equal to 2, correct? Now z of head tile, how many heads are there? 1. How many tiles are there? 1. So 1 minus 1. So what will be the answer? Equal to 0, correct? The first one, 2 head, there is no tile. That is why 2 minus 0, that is 2. Now here z of th, how many heads are there? 1 minus how many tile? 1. So 1 minus 1 equal to 0, correct? Now z of tile means there is no head, that means 0, minus how many tiles are there? 2. So 0 minus 2 means we are getting minus 2. That means what are the numbers that random variable x taking? What are the values? 0 taking and 2 and minus 2. 0, 2 and minus 2, that are the values of the random variable z, sorry, not x, z values, okay? And here it is y random variable. So z take the values 0, 2 and minus 2. So in a single sample space, in a one sample space, we are defined here 3 random variables. X is a random variable, number of heads, y is a random variable, number of tiles, and z is a random variable. We are getting head, number of head minus number of tail. Okay, so that is the remark we are written here. In a sample space we can define more than one random variable. Hope you understood what is the meaning of random variable, correct? Associated with each outcome we are defining a number, okay, real number. So that is the random value, so value of the random variable x. Now let me go to the next definition. Okay, just a brief idea we are giving here. Now a random variable may be discrete or continuous. Okay, random variable we are defining, we are classifying two category. One is discrete random variable, second one is continuous random variable. Okay, this section mainly we are concentrating discrete random variable only. So you can see what is the meaning of discrete random variable. A discrete random variable takes a set of separate values, single separate numbers we are getting. Okay, separate numbers we are getting, or whose outcomes are countable. We can count how many outcomes are there in the sample space, correct? Like that random variable we are calling discrete random variable. So discrete random variable takes separate values such as 0, 1, 2, 3, like that numbers, correct? Or outcomes are countable. For example, see, four cards are drawn random from a well shuffled pack of 52 cards. We have 52 cards are there. From that we are choosing 4 cards at random. Okay, hope you understood the experiment. See, we have totally 52 cards are there. From that I am selecting randomly 4 cards. This is the first card, this is the second card, third card and fourth card, correct? These 4 card I am selecting. Now what is the question is telling? What is the random variable is defining? Let x denote the, x is a random variable that denotes the number of kings, correct? Number of kings. Then what are the values of x taking? You can see number of king card means, you know, totally we have 4 king card only out of 52, correct? Totally we have 4 king card. But when we are selecting 4 cards, sometime all the card will not be king card. Something else, so maybe number 2 card, this is number 3 card, number 4, or jack card, like that. So no king you are getting, nothing, there is no king, correct? So x can take 0 value. That means out of this 4 card, maybe there is no king card. So that means the random variable x taking 0, because x means what is the meaning? Number of kings, correct? Number of king cards. Number of king cards getting. Okay, king cards, when we are choosing number of king cards, how many king cards are getting? Okay, so here no king card. Number 2 card is there, number 3 is there, number 4 is there, jack card is there. Now again I am drawing 4 cards. For some time what happened, I am getting like here number 2, here I am getting 1 king card, and here some other card I am getting number 5 card or number queen card, correct? So how many king cards are there? We are getting out of 4, 1 king card is there. So random variable can take 1 number, correct? 1 number we can take. Now again I am taking like 4 card. What are the possibility? For example, I can get number 3 card, or number queen card maybe here, or king card I am getting, again also king card. So how many king cards we are getting? 2 king cards are there. So what is the next value possible? 2 number possible, correct? Either 0 king card or 1 king card or 2 king card we are getting. Now sometime what happen when we are choosing, here maybe a queen card, and here we are getting king card, here king card getting, here king card is getting. So how many cards king? 3 cards are there. So random variable x take the number 3 also, correct? Number of king cards means 3 king cards we are getting. Now sometime what happen, when we are taking the 4 cards, all cards may be king card. Say like king here, here also king card you are getting, third card also king, fourth card also king card. So what is the next possibility? 4. So what are the values taking the random variable x? Either 0 or 1 or 2 or 3 or 4, correct? These are the possible values of the random variable x. So x takes the values 0, 1, 2, 3 and 4. Maximum 4, because 4 card we are chosen, and maximum 4 king only we have in 52 card, maximum 4 king card only. So 0 will come, or 1 will come, or 2 or 3 or 4. So these are the possible values of the random variable x. So this is like separate numbers, correct? 0 number, 1 number, 2 number, 3 number, 4 number, like separate numbers. So these type of random variables we are calling discrete random variable, separate number or countable numbers. Countable number, you can count how many are there, correct? Countable numbers. So that type of random variable is discrete random variable. Now let me go to the next one, continuous random variable. This we will study later, but now just telling the definition only. Continuous random variable. What is the meaning continuous random variable? Continuous random variable means that takes any value in an interval. Okay, it is defining any value in an interval. For example, 0 less than x less than 5, 0 less than or equal to x less than or equal to 5, like that. From one interval any number we can choose, correct? That type of random variables we are calling the continuous random variable, such as for example 2.7562, any decimal point, any number we can select. That means our outcomes are measured. We can find the number, we can measure the outcome, correct? That type of random variable we are calling continuous random variable. For example, body temperature of patients, body temperature of patients, correct? So when we are taking body temperature, there will be a minimum like 35. For example, I am telling one range, 35 less than or equal to x less than or equal to 37. So any number in between these two numbers is possible, correct? Like that we can take any number, any values in an interval if we are taking, that is what we are calling continuous random variable. Now same another example, height and weight of student, height of the student. If you are taking the height of the students in a class, it is possible any number like in between, for example 140 centimeter to 180 centimeter, for example this one. So it will be a number from 140 less than or equal to x less than or equal to 180. One example only, any height it is possible. Okay, so any number we can take, any value we can take from an interval, means this is what we are calling continuous random variable. So I hope you understood what is the meaning of these two. Now, so here this module, this section 5.4, we are concentrating only the discrete random variable. Discrete random variable only, continuous random variable we are not discussing here. So you can see some picture representing the discrete random variable and continuous random variable. You can see discrete random variable, how the graphs are coming. See discrete value, okay, discrete random variable like this, the numbers separate number. Now continuous means we are defining in an interval. For example, here you can see one normal curve is given. For example, from some number to some number, in between we are just drawing continuous graph. Any value is possible, correct? Any value. But discrete means like separate numbers is possible, correct? Not continuous values, like separate values are doing. So the graph is coming like this. But continuous means we are drawing the continuous graph, continuous function graph like this. Okay, hope you understood the graphical meaning. Now we are coming to the probability distribution of a random variable. What is the meaning of probability distribution of a random variable, of a continuous random variable, sorry, discrete random variable only, not continuous. Probability distribution of a random variable. For example, what is the meaning probability distribution? The values of the random variable along with the corresponding probabilities is calling the probability distribution of a random variable x. That means, see, you can see the table here. For example, x be a random variable of a sample space S, and just define what is the random variable, what numbers possibility of the random variable x of s. Take values x1, x2, x3 up to xn. These are the values of the random variable. Previous example you remember, we are defining the head 1, 0, 1, 2, 3, like that, the values of the random variable, correct? So same like that, the values of the random variables are x1, x2 up to xn. Corresponding probabilities we are defining, probabilities of x equal to xi. Then what is the probability distribution actually? Probability distribution means we are just writing values of the random variable and corresponding probabilities. Okay, for example, see the table, first write x value. X means the random variable value. Okay, for example, x1, x2, x3 up to xn. These are the values of the random variable. Last question you remember, head we are written number of head means 2, correct? 0 possible, 1 possible, 2 possible, like that. So that values we are writing, random variable values we are writing in the first row, and second row we are writing corresponding probabilities, probability of x. That means probability of getting x equal to x1. First random number, random variable getting what is the probability? Second random variable value, what is the probability? Probability of x equal to x3, what is that probability? If you are defining like this, if you are writing like this a table, this table we are calling probability distribution representing that random variable. So what is the meaning? Values of the random variable should be the first row, corresponding probabilities should be the second row. Okay, these are the values of the random variable in the first row, second row corresponding probabilities. This one we are calling probability distribution representing that random variable. Hope you understood that one. Now when we are writing probability distribution, it must satisfy the following condition. These two conditions always we need to check. Okay, if this correct only, we are telling this was the probability distribution. What are the first term? Probability of any random variable should be greater than or equal to 0. That means this number, okay, all these number probability values should be greater than or equal to 0, more than 0, 0 or more than 0, correct? Maximum value, you know, probability maximum value should be 1, correct? So greater than 0 or greater than 0 should be all these places. That is the first case. And second one, if you are adding the probability values, what number you need to get? It should be 1. Sigma summation, correct? You studied in the before module. Sigma from I equal to 1 to n, probability of x equal to xi should be 1. What is the meaning of that one? When we are adding the probability values, that means the second row values, probability of x equal to x1 plus probability of x equal to x2 plus probability of x equal to x3 plus up to the last. Okay, when we are adding, what should be the value you need to get? It should be equal to 1. Then this one we are calling a probability distribution. Hope you understood that one. Let me do one example so that it is clear to you. You can see one example here. From this it is clear to you. If three fair coins are tossed, how many coins are there? 3 fair coins are tossed. Okay, x denote the number of head. Okay, find the values of x, obtain the probability distribution of x. We need to write the values of x, and we need to write what is the probability distribution representing the random variable x. So how to do this one? We are 3 coins are tossing, correct? 3 coins are tossing. So we have first coin, we have second coin, and we have third coin, correct? So first coin, either head will come or tail will come, correct? Now after that, once first coin head showing, second coin, what are the possible? Either head will come or tail will come. Same as if you get first tail, second one either head will come or tail will come, correct? Now same way when we are going to third coin, first toss you get head, second toss you got head, third toss may be either head or tail, same possibility. Now here also either head or tail, here also the either head or tail we are getting, here also either head or tail, correct? So this is the tree diagram representing that random experiment. Now what are the outcomes we are getting in the sample space? First coin head, second coin head, third coin also head. So head, correct? H and H. Now what is the second outcome possibility? First one head, second one also head, third one tail. So we can represent like head and tail, correct? Same like we can write all the outcomes here. You will get the sample space here like this. Sample space equal to head tail, head tail, and tail head, or tail head tail, or tail head, or tail, correct? From all this we are getting from here. One by one you can see there will be 8 outcomes will be there in the sample space, correct? All the outcomes you can see here, head tail head, correct? And head tail and tail head, tail head tail, and tail head, tail and tail. Hope you understood that one, correct? So in this random experiment, we studied before that idea. In this random experiment, this is the sample space. Okay, how many elements are there in the sample space? Number of elements of the sample space equal to 8 elements are there, correct? Now find the x. That is the first part of the question. Find x. Find the random variable x. What is the meaning x actually? Number of heads. X means number of heads, number of heads in each outcome. For example, first we are taking head, head, head. So how many heads are there? Equal to 3, correct? Same like we are calculating all the outcome. Head, head, tile means there are 2. Head, tile, head means 2 heads are there. Head, tile, tile means only 1 head. Okay, like this we are getting all possible values of the random variable x we are getting here. So what are the possible values? X takes the values 0, 1, 2 and 3. 0 coming, how many times is 0 coming? Only 1 time, correct? The number 0 coming only 1 time. If I am writing here 0, 1, 2 and 3. These are the possible values 0, 1, 2 and 3. 0 coming, how many times it is? Only 1 time, correct? Only 1 time it is coming, 0 number. 1 coming how many times actually? 1 here is there, here is there, here is there. 3 times, correct? So this number random variable 1 coming 3 times. I am just writing here 3 times, correct? 0 coming 1 time. Now number 2. Number 2 coming how many times are coming? You can just check. 2 here, here also 2, here also 2. Here also how many times it will come? 3 times it will come, correct? Now number 3. Number 3 how many times is coming? Only 1 time, here only, correct? So we can write 1 time is coming, okay? So 1 time. So totally in the sample space we have 8 numbers, remember that one. And the random variable x takes the value 0, 1, 2, 3, where 0 coming 1 time, 1 coming 3 times, 2 coming 3 times and 3 coming 1 times. But the values of x are 0, 1, 2 and 3. This is what the first part of the question. What are the values of x, random variable x? So x taking 0, 1, 2 and 3. Now we will go to the second question answer. This is what important part. Obtain the probability distribution of x. Obtained the probability distribution of x. So what we need to do for that one, for finding the probability distribution? We need to find a table. In this table, what you write? First write the random variable x value. Then you write what is the probability of each random variable. Probability of x. Okay. So what are the random variable here we got? We got 0 number, 1 number and 2 number and 3 number, correct? 0, 1, 2 and 3. These are the values of x. Here we calculated already 0, 1, 2 and 3. X takes 0, 1, 2 and 3. Now we need to write corresponding probabilities here. Probability of x equal to 0. Okay, first cell we need to write what is the probability of x equal to 0. Here we need to write probability of x equal to 1. Here we need to write probability of x equal to 2 and probability of x equal to 3. Okay, these numbers we need to calculate. So how we are calculating actually probability? Probability means number of outcome favorable to that event divided by total number of outcome. You remember we studied in 5.1 section, correct? Probability of an event means what we write? Number of outcomes favorable to that event divided by total number of outcomes in the sample space. This is the probability of a event x, correct? Now same way here you can see, for example, first we need to take probability of x equal to 0, correct? Probability of x equal to 0. X equal to 0 favorable, how many outcomes are there? Only one outcome. What is that outcome? X equal to 0, tile, tile and tile. Hope you understood. See, x of tile, tile, tile equal to 0, correct? So only one time coming that number 0. What is that number outcome actually? Tile, tile, tile. So how many favorable outcomes? Only one outcome. Divided by total number of elements in the sample space, what? 8. So what will be the probability of x equal to 0? 1 divided by 8. Hope you understood that one, correct? Because probability of x equal to 0 means, what is that one? Probability of the outcome x equal to 0 means tile, 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 correct? Because x means number of head. Number of head 0 means tile, tile, tile. How many outcomes? Only one outcome, tile, tile, tile. So 1 divided by total number of elements in the sample space is 8. Hope you understood that one. So it is equal to 1 over 8. Now same like probability of x equal to 1. X equal to 1, how many outcomes are there? 3 times. 3 times it is coming. So what are the outcomes x equal to 1? You can see here. Tile, tile, head. That is 1. Tile, tile, head. What is the next one? Tile, head, tile. Tile, head, tile. What is the third one? Head, tile, tile. Correct? Head, tile and tile. So how many outcomes favorable to that event? 3 outcome. How many outcome totally in the sample space? 8. So what will be the probability of that one? 3 divided by 8. Hope you understood that one, correct? Now, probability of x equal to 2. 2 number, correct? X equal to 2 coming how many times? 3 times are coming, correct? What are the outcomes that one favorable to that even? 3 times. Number 2 coming? Tile head head, correct? Tile head head. What is the next one? Number 2 coming? Head tile head, correct? So head, tile and head. What is the next one? Head head tile. Head and tile. So how many outcomes are there favorable to that even? There are 3, correct? Total number of outcomes equal to 8. So what will be the probability that one? 3 divided by 8. Hope you understood that one. Now probability of x equal to 3. X equal to 3 coming how many times? Only one time. What is that outcome x equal to 3? Head, correct? H. So what will be the probability? Only one outcome divided by total outcomes are 8. So what is the probability? 1 divided by 8 here. This is what we are calling the probability distribution representing that random variable. Okay, probability distribution. I can write probability distribution representing that random variable x. That means we draw a table, write the first row the random variable x values, second row we write corresponding probabilities. Okay, so I hope you understood that one. Now in this table, as I told you in the definition, see the numbers. First number we are representing x1, x2, x3, x4, last number xn. Then here we are representing probability of x1, probability of x2, probability of x3, like that it is last one. So you can study like this. For example, this table, okay. For example, here this is x1, this is x2, this is x3, this is x4, correct? X number, random variable values. First value x, second x2, x3, x4. This is probability of x1 random variable probability, probability of x2. This is probability of x3. This is probability of x4. Hope you understood that one. So this is the second part of our question. Obtained the probability distribution representing the random variable x here. Now, so you conclude like this. See, probability of x equal to 0. In detail I am written here. Probability of x equal to 0, 1 over 8. Probability of x equal to 1, that is 3 over 8. Probability of x equal to 2, 3 over 8. X equal to 3, 1 over 8. So we are writing x number and corresponding probabilities like this. This is what we are calling probability distribution representing the random variable x here. Hope you understood that one. Now whenever we are doing the probability distribution, all these numbers should be greater than or equal to 0. We studied that one just before. Probability of all xi should be greater than or equal to 0. All probability values should be more than 0, not negative number. Okay, and if you are adding the probability value, sum, sigma, sum means adding. Okay, sum of the probability values, sum of the pxi, probability of the xi should be maximum. How much you need to get? Should be 1, correct? For example, if you add 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, you should be get what number? Equal to 1. Then only we can say that is a probability distribution. Okay, so these two conditions all of you keep in your mind. Always the probability value should be more than, greater than or equal to 0, and sum of the probability values should be equal to 1 here. Now I am going to the next definition. So all of you got the idea how to write the random variable and how to write the probability distribution. Okay, now the idea is easy if you are understood that too. Next point we need to study expected value or mean of a random variable. We are telling expected value or mean, or it is same like average only, weighted average. We are telling, you know how to calculate the average, correct? The same idea, weighted average. So expected value or mean of a random variable. Okay, so x be a random variable, possible values are x1, x2 up to xn, occur with probabilities, probability x1, probability x2, probability x3. Okay, just remember the last example. Okay, what do you do? First we form the x numbers. First row writing x number, x1, x2, x3, like that. Second row we are writing probability values. Just now we discussed that example like this, correct? X values, probability values. Now, probability values are probability of x1, probability of x2, probability of x3, like that it is continuing. Now, the mean of x, mean or expectation of x, expected value of x, denoted by either we are using this one E of x, that means expected value of the random variable x. Otherwise, we are representing using this symbol, mu symbol, okay, mu symbol, and it is defined by expectation of x equal to or mu equal to what we are doing, sigma xi multiply pxi, okay, or simple way you study this one, expectation of x equal to, you can study this rule, expectation of x or mu equal to x1 multiply probability of x1, that means this value multiply the probability of x1 plus the second value x2 multiply the probability of x2 plus the third value x3 multiply the probability of x3 plus like that continuing up to the end, xn multiply probability of xn. Hope you understood how we are calculating the mean or expected value. Just multiply the random variable value together with its probability, x1 multiply probability of x1, x2 multiply probability of x2, x3 multiply probability of x3, like that up to the end. This value we are calling the expected value or mean of a random variable x. It is easy idea, just to remember this rule. Now you can see some note here, mean of a random variable x is just like a weighted average. Maybe you studied before, weighted average calculation, correct, of the possible values of x, which beginning weighted by its probability, here weight being weighted by its probability, okay, with which it occurs. So this is the idea, expected value or mean of a random variable x. Okay, now let me go to the variance, the next idea we are calling variance of a random variable. Okay, now the mean of the random variable does not give a information about the variability of the values of the random variable, correct. That means if you define a random variable with different probability distribution can have equal mean sometime, correct. In a one sample space, if you are defining the random variable, maybe same mean will be there. So how to separate, how we are checking the variability of the random variable, that means random variable does mean of the random variable does not give the information about the variability. So for that we are using variance of a random variable. Okay, so what is the variance? You can see x be a random variable, possible values are x1 x2 up to xn, probabilities are probability x1 probability x2, like that. You can see the table same like before, x1 x2 x3 probability, writing the second row. Now expectation of x already we studied, mu, correct. Expectation of x equal to mu, mean of the x. Variance of x is denoted by, we can use this one, var x, variance of x. Otherwise we are using this symbol, sigma square. This notation is calling sigma square, this one sigma square, okay, this is calling sigma notation. This is small letter sigma, okay. You maybe summation, you operator sigma you studied this one before. This is also we are calling sigma, but is summation, we are using the summation operation. This is actually a capital sigma, okay. Sometimes we are calling sigma only, this is the capital sigma, okay. So summation. So variance we are representing by using the small letter sigma, Greek letter this is, okay, variance of x equal to sigma square. So this is the Greek letter small sigma, sigma square, or we can use variance of x, or you can use this one sigma square of x. X is the random variable. One of the symbol you can use for representing variance. Now variance of x equal to sigma square equal to, how we are defining, sigma xi minus mu whole square multiply probability of xi minus mu power 2 multiply probability of x. Otherwise we can write like this, expectation of x minus mu whole power 2, because you know expectation of x means, you remember, sigma xi multiply probability of xi, x1 p1, x1 probability of x1, x2 probability of x2, like that. Here xi minus mu whole power 2, that means each random variable value subtract the mean, okay, square, multiply probability of xi, or we can represent like this, expectation of x minus mu whole power 2 here, because we are getting that from here. Okay, expectation of x minus mu all power 2. I hope you understood that one. Just remember this rule. I will explain when we are doing question this idea more easily. Okay, now we will come to the standard deviation. Next idea, standard deviation. Standard deviation of a random variable x means square root of the variance. Whatever the variance answer you got, take the root of that number, root of variance. That is we are calling standard deviation. Standard deviation we are representing sigma notation. Okay, sigma means standard deviation. Sigma square means, I told you now, variance, correct? Variance notation. Now there are some properties of variance. You can see variance of k multiply x. K is a constant, so variance of k multiply x equal to k square multiply variance of x. Okay, I'm not going to the proof of that one, just remember that idea. Okay, that constant, if it is coming outside, means k square multiply variance of x. Now variance of x plus k means variance of x only, because k variance is 0. Constant means variance is 0. Constant with random variable means taking outside means k square multiply variance of x. Now variance of x always should be greater than or equal to 0, and it is 0 if probability of x equal to 1. Okay, now this is the rule. Better to use the finding the calculating the variance of x in practical questions. Variance of x equal to expectation of x square minus expectation of x whole square. Expectation of x means, you know, mean, correct? Mu. Expectation of x square we can calculate by using this rule. Expectation of x square equal to x square multiply probability of that random variable. I will tell you when we are doing questions more. Now expected value, okay, expected value is also known as the first moment of the random variable, first moment, and variance of x we are calling second moment of the random variable x here. Now let me go to one example for all these things. So what we studied now, how to find the expectation or mean, how to find the variance, and how to find the standard deviation. All these things I will explain in this example so that it is clear. After that we will go to the exercise questions. Okay, for example, a fair coin tossed twice. 2 times a coin is tossing, correct? X denotes the number of tiles. X means the random variable x denotes the number of tiles. Now what is the question? Find the probability distribution of x. Probability distribution means we need to draw the table. Okay, first we need to write x values, and second one we need to write probability values, correct? So we need to first find probability distribution. This is the first question. After that, second question, calculate the mean, variance, and standard deviation. SD means standard deviation. Okay, mean means expectation of x, variance means variance of x, SD means standard deviation. So what are the question we need to do? We need to calculate mean first, expectation of x. Okay, or we can use mu symbol also. Second one, we need to calculate variance of x, otherwise which symbol? Sigma square. Third one, we need to calculate standard deviation, otherwise which symbol? Sigma symbol. These are the 3 ideas in the second part. Okay, so we will do one by one. So first see the random experiment. A coin tossing 2 times. So what will be the sample space? S equal to either head will come, or head tile will come, or tile head will come, or tile will come, correct? There are 4 possible outcomes are there. So how many elements are there in sample space? Number of elements of sample space equal to 4, correct? Now what is the random variable x defining here? X is the number of tiles. X means number of tiles. So you can take how many tiles are there, each outcome. Head, correct? How many heads are how many tiles are there? How many tiles? Number of tiles. There are 0, nothing is there. Now head tile, how many tiles are there? Only 1. Tile head, how many tiles are there? 1. Tile, how many are there? 2 tiles are there. So what are the possible values of the random variable x? X of head, x of head tile, x of tile head, x of tile we calculated. So what are the possible values of x? X takes the values, either 0 will come, or 1 will come, or 2 will come, correct? So x values we got 0, 1 and 2. Now what we need to calculate? We need to do corresponding probabilities, correct? Corresponding probabilities we need to write, correct? So what are the corresponding probabilities? For example, x equal to 0. So x values I wrote in the first table, 0, 1 and 2, correct? Now, how we are calculating the probabilities? As I told you just before, one example, x equal to 0, probability of x equal to 0. What is the probability? X equal to 0 coming how many times? You can see, I will show here, x values are 0, 1 and 2, correct? Only these three number. Now, 0 coming how many times? You can see here, how many times 0 coming? Only one time, correct? So, one time. What is that outcome actually? Head, head, correct? One time is coming, that is head, head. We written here. Now, 1 coming 2 times here, correct? So, the random variable 1 coming 2 times. What are the outcomes that one? One is head tile, second one tile head, correct? Now, random variable 2 coming how many times? You can see only one time, okay? What is that outcome? Tile, tile, correct? So, I can write one time. Outcomes are tile and tile. Hope you understood, correct? So, random variable value 0, 1 and 2. Now, I am just writing what are the probability of x, correct? So, probability of x we are writing 0. What is the probability x equal to 0? What is the probability x equal to 1? And what is the probability x equal to 2, correct? So, first I am writing probability of x equal to 0. How many outcomes are there in x equal to 0? Only one outcome. What is that? Head, head, correct? So, number of outcomes 1. Totally how many outcomes are there in sample space? 4. We written here number of elements of the sample space equal to 4, correct? So, what will be the probability? One outcome favorable to that event divided by totally 4. 1 over 4. 1 over 4 means what is that number? 0.25, correct? So, probability of x equal to 0 means 0.25. Now, probability of x equal to 1. I want to write here probability of x equal to 1. X equal to 1, how many outcomes are there? Head tile, tile head. So, 2 outcomes, correct? 2 outcomes. So, what is the probability? 2 divided by total number of outcomes 4 in the sample space, correct? Number of outcomes favorable to that event divided by total number of outcomes. So, 2 divided by 4. 2 divided by 4 means 1 divided by 2, 0.5. Now, probability of x equal to 1. How many outcomes are there x equal to 1? Only tile, only 1. So, 1 divided by totally 4 outcomes, 1 over 4 equal to 0.25. Hope you understood that one, 0.25. So, when we are writing x and p of x, this is what we are calling probability distribution, correct? Probability distribution. Hope you understood this one, how to calculate the probability distribution. This is what I wrote here, x write first, second probability of x. Now, for calculating variance, because second part variance question is there, so better to do x square also here. Just to square of the x number, okay? 0 square 0, 1 square 1, 2 square 4, x number square. This is x square, this is x1, 1 square is 1, 2 square, that is equal to 4 here. Hope you understood that one. So, probability distribution x square not necessary. Why we are written x square here? Because we need to calculate variance here. For that we need to use x square. So, I am writing here itself that one x square. So, first part of the question is over. How to calculate the probability distribution. Probability distribution means x value and probability value together we are writing. That is the probability distribution. Now, I am going to the second part of the question. Calculate the mean of the random variable, variance and standard deviation, correct? Now, what is the rule for finding mean we are studied? Mean means, first we are calculating mean. Mean means expectation of x, or we are representing mu letter. Mu equal to what we are doing? x1 multiply p of p1 px1, x2 multiply px2, x3 multiply px3, adding this number, correct? The random variable multiply with the corresponding probabilities. That is what we are calling the mean of the random variable or expected value. x1 multiply p1x, px1 probability of x1. x2 multiply probability of x2, x3 multiply probability of x3. Add these numbers, correct? For example, what was our table? You can see our table, I am just drawing here better. X, p of x, correct? 1, here we got 0.25, sorry, 0, 0, 0.25, 1, 0.5, and the third one, 2, 0.25, correct? This was the table. Now what you do? Just multiply x number with its probability. So 0 multiply 0.25, correct? This is the x1 number. This is p x1, correct? Probability of x1. This is x2. This is probability of x2, correct? This is x3. This is probability of x3. Okay, so x number multiply with its probability. 0 multiply 0.25 plus 1 multiply 0.5 plus 2 multiply 0.25. Answer equal to 1. That is what we are calling expectation of x or mu value. Hope you understood that one. Easy calculation, how to calculate the expected value. Now we are going to do variance of x. Variance of x means this is the rule for finding variance. Variance of x means sigma square. Variance of x or sigma square means expectation of x square minus expectation of x whole square. This is the rule. Okay, easy rule this one. You can memorize this one. Expectation of x square minus expectation of x whole square. Okay, expectation of x square. This is we need to calculate. Minus expectation of x means mean, correct? Whole square, mean square, or expectation of x square. Now, how to calculate that one? You can see, first calculate this one, expectation of x square. Okay, this value first we are calculating. So, how to calculate expectation of x square? x1 square multiply probability of x1. x1 square, that square will come here. x1 square, probability of x1. x2 square, probability of x2. x3 square, probability of x3. Correct? Already we calculated what is x1 square, x2 square, x3 square on the table. Correct? What are the x1 square? x1 number square, 0 square, 0. 1 square, 1. 2 square, 4. You remember we are created here that x square value here. 0, 1 and 4. This number and probability value multiply and add. You will get the expectation of x square. So 0 multiply 0.25. 1 multiply 0.5. 4 multiply 0.25. Like this. Okay. That is the meaning expectation of x square. Okay. Expectation of x means only x1. Square means x square. Okay. So x1 square, probability of x1, you will get 0 multiply 0.25 plus 1 multiply 0.5. 4 multiply 0.25. So answer is 1.5. Hope you understood. Now apply this value here in variance. Variance of x equal to sigma square equal to expectation of x square. Just now we got what is the number? 1.5. Expectation of x already we calculated here the mu value, mean value. So 1.5 minus 1 square. Here we need to do square because expectation value whole square. Okay. So 1 square equal to 0.50. This is the variance of x. Hope you understood. Now from variance of x, how we are calculating standard deviation? Sigma. Standard deviation means root of variance. Root of variance. Variance is 0.5. So root of 0.5, you will get this number. This is the variance of the random variable x. Hope you understood that one. Now, what are the things we studied this 5.4 section? What are the formulas? You can see. These are the formula you need to memorize. How to calculate the mean first. Okay, how to calculate the mean? Expectation of x equal to mu equal to x1 probability of x1 plus x2 probability of x2, like that it is continuing. Expectation of x square, how to calculate? X1 power 2 probability of x1, x1 power x2 power 2 probability of x2, like that continuing. Variance of x, correct? Another one, variance of x, sigma square equal to expectation of x square minus expectation of x whole square. Standard deviation, correct? Standard deviation means root of variance of x. Variance of x, whatever you got, root of that number. So memorize these rules. These are the rules in 5.4 section B needed. Okay, let me start with examples now. Exercise questions. Okay, one by one we will do. What is the first question? Check whether the following are probability distribution or not. This is the question. Check whether the following are probability distribution or not of a random variable x. Correct? Probability distribution or not of a random variable x. See, one table is given. This is representing probability distribution or not. How we are checking probability distribution or not? First we need to check probability of xi should be greater than or equal to 0. All the probability values should be more than 0. Correct? 0 or more than 0. Second one, what is the condition? When we are adding sigma means add. Sigma of adding of probability values. Probability xi answer should be equal to 1. These two conditions if correct, then that table we are calling probability distribution. Okay, so here we check first. Check the number first, probability. Here see, first probability value is 0.4, second also 0.4, third 0.2. All the number are greater than 0, greater than or equal to 0. Correct? Positive numbers greater than or equal to 0 also okay. So the first condition is okay here. So no? Yes, correct? Because probability of x1. See, this is x1. This is x2. This is x3. This is probability of x1. This is probability of x2. This is probability of x3. Correct? So what we can write the first condition? Probability of xi. That means probability of x1. Okay, and probability of x2, probability of x3, probability of x3, all are greater than or equal to 0. First condition is okay. All are okay more than 0. So we can write probability of xi greater than or equal to 0. Yes or no? x1, x2, x3, all probabilities are greater than or equal to 0. Hope you understood, because if you want in details, you can see probability of x1 0.4 greater than or equal to 0. Correct? Probability of x2 0.4, that also greater than or equal to 0. Probability of x3, that means 0.2, that also greater than or equal to 0. Positive numbers. Correct? Now second condition. So first condition is okay. Second condition, what we need to check? Sum of the probability should be 1. Okay, so what is the meaning of that one? If you add probability of x1 plus probability of x2 plus probability of x3, check what is the answer getting. It should be 1. Correct? So what is the value here? What is probability of x1? 0.4. Probability of x2 0.4. Probability of x3 0.2. So what answer getting? Equal to 1. Correct? So both are satisfied. So this representing probability distribution or not? Yes, representing probability distribution. So we can write the answer yes, that data is representing probability distribution. Hope you understood. Okay, now let me go to the second question. This one, we are getting a table here. Is it represent a probability distribution or not? 0, 1, 2, 3, 4. That is the random variable values. Okay, so this is x1, x2, x3, x4, x5. Correct? There are 5 numbers given. Now this is probability of x1, probability of x2, probability of x3, probability of x4, probability of x5. Correct? Check all the number greater than or equal to 0. No, one number is negative number here. You can see. Correct? Which number is that one? Probability of x4. So what we can write? The first condition is satisfied? No, because here probability of x4, that means minus 0.1. It is not greater than or equal to 0. It is less than 0. Correct? Otherwise not greater than or equal to 0. Correct? Not satisfied. So this is not representing a probability distribution. Yes. Second question, second part is no need to check. First part also not okay means no need to go second one. If you check second part, what happens? See, sigma summation of the probability. What is the summation of the probability? Probability of x1 plus probability of x2 plus probability of x3 plus probability of x4 plus probability of x5 equal to, what is the number? 0.1 plus 0.5 plus 0.2 plus minus 0.1 plus 0.3, correct? This is answer 1 is getting. But what is the problem? Problem here in the first part, correct? Probabilities are not greater than or equal to 0. This is not satisfied, correct? So what is the answer? This is not representing a probability distribution, correct? Not a probability distribution of random variable x. Hope you understood that one. Second condition okay, but first condition not satisfied. Okay. Now we will go to the third question. Second question, that means a random variable x has the following probability distribution. Already probability distribution is given. The random variable x having the following probability distribution. Determine what is the value of k. Find what is the probability x less than 4. What is the probability 2 less than x less than 5? This is the question. Okay. So you can see the question here. This is x1, x2, x3, 4, 5, 6, 7, 8 and 9, correct? There are 9 numbers are there, 9 values taking the random variable x. Corresponding probability is also given, correct? This is probability of x1, this is probability of x2, probability of x3, probability of x4, probability of x5, 6, 7, 8, x9, correct? Probability of x9. Now what is the first question we need to do? Determine the values of k. How can we calculate the values of k? You know how to calculate that one. What we do for that one? We already studied, if that table representing probability distribution, what will be the sum of the probability value? Sum of the probability values, sum of the probability xi should be equal to how much? Equal to 1, correct? This is the condition for finding the k value here. So let me start the answer one by one. So first question answer I am doing here, the first part. Okay, determine the values of k, value of k, that is the first part of the question. So how to get the value of k? Because this represents a probability distribution means summation sigma. When we are adding probability values, what answer you should get? Should get equal to 1, correct? That means probability of x1 plus probability of x2 plus up to probability of x9, you will get value equal to 1, correct? So what are the probability values? That means k plus 3k plus 5k plus 7k plus 8k 11k plus 0 plus k plus 3k. Okay, all the probability values when we are adding, answer should be equal to how much? 1, correct? Equal to 1. Now you know how to calculate that one. Add all these k plus 3k plus 5k, all the k when you are adding, you can check, you will get 39 times k equal to 1. 39 times k equal to 1. From this you will get what is the k value, correct? K equal to how much? 1 divided by 39. You can divide both sides by 39 like this, correct? So 39 will cancel. So answer is k equal to 1 divided by 39. This is the first part of the question. Easy question, but only the idea remember what is the meaning of probability distribution. Sum of the probability should be 1, correct? So k equal to 1 over 39. So first part of the answer we got. Now we will go to the second part of the question. Okay, probability of x less than 4. Probability of x value less than 4 equal to. This is the second part. Now probability x less than 4. What are the values of x here? 0, 1, 2, 3 up to 8. Correct. Now x less than 4 means what are the x numbers? X below 4. 4 is not included because x less than 4. Correct. Below, not equal. So what are the x below 4? What are the numbers below 4? 0, 1, 2, 3. Correct. 0 number, 1 number, 2 number and 3 number. So probability of x less than 4 means, what is the meaning? Probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. Correct? Probability x less than 4 means less than 4, all the number you write, probabilities, corresponding probabilities. Okay, that is the meaning. Equal to, what is probability x equal to 0? You can check in the table. What is probability x equal to 4? K, probability value. Okay, probability x equal to 0 means k, plus what is probability x equal to 1? You can check the table, 3k. Correct? So we can write 3k plus probability x equal to 2 means 5k, x equal to 3 means 7k. Correct? So we can write 5k plus 7k. So totally how much we got? 16 multiply k. Correct? 16 times k when we are adding. Now k number you know. So apply the k number. 16 multiply. What is the k value? 1 divided by 39. We calculated just now here k value 1 by 39. So what will be the answer? 16 divided by 39. You can check the calculator. 16 divided by 39. Hope you understood. Correct? Now we will go to the third part of the question. What is the third part? Probability of 2 less than x less than 5. Probability of 2 less than x less than 5 we need to calculate. That means x values from 2 to 5. 2 is not included because here is less than, not equal. Correct? So 2 value not included, 5 number not included. In between, what are the x numbers coming? Okay. So what are the number in between? Probability of x equal to 3 will be there, plus probability of x equal to 4 will be there. Correct? 5 is not included, 2 also not included. In between, what are the values of the random variable? X equal to 3 and x equal to 4. Now check in the table what is probability x equal to 3. X equal to 3 what? 7k. Correct? So we can write 7k plus probability of x equal to 4 means 8k. So we can write 8k. So 7k plus 8k means 15k. K number you can substitute. So 15 multiply, what is the k number? 1 divided by 39. So what answer we will get? 15 divided by 39. Hope you understood that question. So this is the question here, the idea. Determine k. Determine the probabilities, okay, corresponding probabilities. Okay, let me go to the third question now. Same model, one more question. Question number 3 here. A random variable x takes the values following probability distribution. Okay, probability distribution is given. Already probability distribution is given. 0, 1, 2, 3, 4, 5 up to 7. So this is x1, x2, x3, x4, x5, x6, x7 and x8. Correct? Corresponding probability is given. Probability x1, probability x2, probability of x3, okay, 5, probability of x7 and probability of x8 already given here. Determine the value of k. That is the first question. What is the k value? Same like before. Determine the k value and calculate probability of x greater than or equal to 6. Probability of 0 less than x less than 3. So we will do one by one. First part of the question. K value how we are calculating? Just to take the condition probability distribution. Correct? Probability distribution means, what is the meaning I told? If it is a probability distribution representing, then the sum of the probabilities, sigma p of xi, probability of xi, sum of the probability should be 1 here. So just add the probabilities. What are the probabilities? 0 plus k plus 2k, like that all. 0 plus k plus 2 times k plus 2k, 3k plus k square plus 2k square plus 7k square plus k equal to 1. Okay. Now just add the k terms first and the k square term also. K square term add separately, k term add separately. What are the k square term? You can see here 1 k square is there, here 2 k square is there, here 7 k square is there. So k square plus 2 k square plus 7 k square, how much it will be? That one that is equal to 10 k square, correct? 10 times k power 2. Now k terms add. What are the k term? K plus 2k, 3k, 3k plus 2k, 5k, 5 plus 3k, that is 8k, 8k plus 1k, sorry, that means k, 3k, 5k, 8k, and plus one more k will come, 9k. So 9k, then equal to 1, correct? Take all together one side. So how you will get it? 10k square plus 9k minus 1 equal to 0. Now you know how to solve this one using calculator, correct? We studied before sections. Use the calculator. So 10k power 2 plus 9k minus 1 equal to 0. Okay, what we do? Press the mode button. You know that one. After that, equation number 5. After that, ax power 2 plus bx plus c, number 3. Then you apply the a number. Calculator will ask a number is 10, press equal to, b number is 9, c number is minus 1. So once you enter, you will get the numbers there. What are the number? X1 number and x2 number you will get, correct? X1 number is you will get 1 over 10 from calculator. X2 number is minus 1. Two answer we will get from the calculator. One is 1 over 10, second one minus 1. Okay, press the calculator, equal to 1 by 1 you will get. Okay, so these are the behind number. A number is this, b number is this one, c number is minus 1. You know that one. So what are the k values we are getting? K equals 1 over 10, and second one minus 1. Minus 1 we will not take that one. Why minus 1 we are not taking? Because probability should not be negative, correct? Because k number here it is given probabilities. Okay, so probability should not be negative. So this number not possible. Probability should not be negative. Okay, so negative value not possible, only take the positive value. So what is the k value we got? K equal to 1 over 10 we are getting. I hope you understood the first part of the question. Right, determine the k value. Now I will go to the second part of the question. Probability of x greater than or equal to 6. Calculate probability of x greater than or equal to 6. Probability of x greater than or equal to 6. X greater than or equal to 6 means the random variable x taking 6 or more than 6. So what are the numbers you take more than 6? 6 or more than, equal symbol is there, correct? So 6 number and 7 number, correct? So we can write probability of x equal to 6 plus probability of x equal to 7 number. Now check this number in calculator. What is probability of x equal to 6? 2k square. Probability of x equal to 7, 7k square plus k. So we are writing here, okay, that numbers. First number 2k square plus x equal to 7 means 7k square plus k. Now you can simplify. 2k square plus 7k square means 9k square plus k, correct? Now you know what is the k value. K value is given, find here 1 over 10. So apply here 9 multiply 1 over 10 power 2 plus 1 over 10. So you will get the answer equal to, when we are simplification, 19 divided by 100. You can simplify also by using calculator, point number also, okay. So 19 divided by 100. So this is the second part. Now third part of the question. Probability of 0 less than x less than 3. Okay, next question. Question number 3. Probability of 0 less than x less than 3, correct? So 0 and 3 in between. 0 is not included, 3 also not included. So what are the values taking? probability x equal to 1, probability x equal to 2. So probability x equal to 1 from the table you can see what is x equal to 1, x equal to 1 k, correct, plus x equal to 2 2k. So k plus 2k, so that means equal to 3k, correct. Now 3 multiply k number apply 1 over 10. So 3 multiply 1 over 10 means 3 over 10. So this is the answer of that question. Hope you understood that one. Okay, now let me go to the fourth question. Okay, question number 4. What is the question? Now we are doing the main questions. Find the expectation of x or mu and variance of the following distribution. We need to calculate what is the expectation of x and what is the variance from the following probability distributions, correct. So first we will start the expected value or expectation of x, or you can represent mu, correct. One of the symbol you can use, no need both. So expectation of x equal to or mu equal to, what was the rule we are studied? x1 multiply probability of x1 plus x2 multiply probability of x2, correct. x2 multiply probability of x2 plus x3 multiply probability of x3. This table already given all values. This is x1, this is probability of x1, this is x2, probability of x2, x3, probability of x3, correct. Just apply the numbers one by one. x1 means 2 multiply probability of x1 means 1 over 4 plus x2 means 5, probability of x2 means 1 over 2 plus x3 means 10, probability of x3 means 1 over 4. Now when you are calculating you will get the mean equal to 11 divided by 2, 11 divided by 2. This is the expectation of x, otherwise mu equal to 11 divided by 2. Now we need to calculate now what is the variance of the distribution, okay, variance of the random variable x. So let me start now the variance of x, where x equal to, what is the rule we studied? Expectation of x square minus expectation of x whole square, correct, expectation of x whole square. So let me calculate these things. So equal to, see, expectation of x square, this value we don't know. First we need to calculate this one. This value already we know, expectation of x mean, just now we calculated here 11 by 2, correct. So what we need to do, we need to calculate the first number, okay, we need to calculate this first number minus second number already we know, expectation of x square, second number is what, 11 divided by 2 square, whole square, expectation of x whole square. Now how we calculate this expectation of x square, you can see what is our table, you know, what's our table? 2, 5, 10, x values 2, 5, 10, correct. Probabilities, what are the probabilities here? 1 over 4, 1 over 2, 1 over 4, 1 over 4, 1 over 2, 1 over 4, correct. Now how to calculate expectation of x square? Expectation of x square equal, what is the rule actually? x1 square multiply probability of x1 plus x2 square multiply probability of x2 plus x3 square multiply probability of x3, correct. So we need to calculate we need to create one extra table, or you can do direct also, no issue. One extra table, that is x square, okay, x number square you can write here. For example 2 number square 4, 5 number square 25, 10 number square 100, correct, 100. Now you apply here x1 square, what is x1 square? 4, okay, multiply probability same 1 over 4 plus x2 square 25 multiply probability same 1 over 2 plus x3 square 100 multiply probability 1 over 4, correct? So when you are checking your calculator, you will get this one 77 divided by 2. Point number also okay. 77 divided by 2 we will get it. Now apply that number here. Expectation of x square means 77 divided by 2 minus 11 by 2 square. Now you can simplify, check by calculator what you are getting. 33 divided by 4. This is the variance of x. Variance of x means sigma square. You can use var x or sigma square. Both symbols are okay. Variance of x equal to 33 divided by 4. Hope you understood this question. How to calculate expectation and how to calculate the variance of x. Now if you want the standard deviation, same question. It is not asked in the question. Now if you want standard deviation or sigma, what you do? Just to take the root of the variance. Root of the variance number. That means root of 33 divided by 4 we are getting. That you can check by calculator. This question not asked, but I am just doing here. Root of 33 divided by 4. So that you will get the answer like 2.87 approximately. Okay. So ideas are easy, calculating mean, variance and standard deviation. Okay, now let me go to the next question. The same question, calculate the expected value and variance here. Okay, so let's start now. I hope you understood now. Here this is x1, x2, x3, x4. Okay, this is probability of x1, probability of x2, probability of x3 and probability of x4. So first calculate the mean, expectation of x. Otherwise we can use the symbol mu. What is the rule? x1, probability of x1 plus x2, probability of x2 plus x3, probability of x3 plus x4, probability of x4. Apply the numbers one by one, x1 number and corresponding probability numbers. Okay, so you will get 2 multiply 0.1 plus 3 multiply 0.2 plus 4 multiply 0.3 plus 5 multiply 0.4. So the answer when you are calculating, you will get 4. Now we need to calculate what is the variance. So before that, what we need to calculate? Expectation of x square, correct? What is expectation of x square? x1 square, probability of x1, x2 square, probability of x2 plus x3 square, probability of x3 plus x4 square, probability of x4, correct? So for that I told, if you want you can add one row here representing x square. For example 2 square 4, 3 square 9, 4 square 16, 5 square 25, like this. Okay, now you can apply here x1 square. What is x1 square? 4, probability 0.1 plus x2 square 9, probability 0.2. Probability same as that middle row, only x square, these numbers changing, plus x3 square 16, probability 0.3 plus x4 square 25, probability 0.4. So after calculation you will get equal to 17. Okay, now from this we need to calculate what is variance of x. Okay, variance of x equal to, what is the rule? Variance of x we studied, expectation of x square minus expectation of x whole square, correct? So you can get it, expectation of x square we got 17 minus expectation of x means 4 square So you will get variance equal to 1. Hope you understood that question. Now same question I told you, if you want to calculate standard deviation, what we do, standard deviation means sigma, variance means sigma square. So standard deviation, what you do, root of variance, correct? That means root of 1. You will get equal to 1 here. Hope you understood. Next question, question number 5. An unbiased die is thrown twice. A die is throwing twice, okay? X denotes the sum of the numbers. Sum of the numbers, okay? When we are doing sum of the numbers, that is the x value. Find the value of x, obtain the probability distribution of x, and find the expected value, variance, and standard deviation from this question. That is what, okay, our question here. So let me go to this question here. First we need to do the sample space. What is the sample space? S equal to unbiased die thrown 2 times. You remember we studied before sections. If you throw a die 2 times, what are the options? 1 will come, or 1 2. Die means 1 to 6 option, but 2 times throwing means 1 1 2 1 3, correct, 1 4 1 5 1 6. Otherwise 2 1 2 2 3 2 5 2 6, correct. Now 3 1 3 2 3 3 3 4 3 5 3 6 4 1 4 2 4 3 4 5 and 4 6. Then 5 1 5 2 5 3 4 5 6, correct. Then lastly 6 1 6 2 6 3 6 4 6 5 6 6, correct. So how many outcomes are there totally? Number of elements of the sample space equal to 36, correct. Number of elements of sample space equal to 36. Hope you understood. Now here, what is the meaning x here? X denotes the sum of the numbers, okay. X means the sum of the numbers. So what are the possible values of x here? If you take each outcome, for example 1 and 1, what is the sum of these two numbers? 1 plus 1 2, correct. Same like we need to calculate all the numbers sum here, okay, all the numbers sum. So 1 1 2, for example 1 2, what is the sum? 3, correct. It is 3. Now here 1 3, what is the sum? 4. 1 4 means 5. 1 5 means 6. 6 1 means 7, correct. Now 2 1 we can go 2 1, that is 3. This is 4. Here 5. Here 6. Here 7. Here 8. Here 4 5 6 7 8 9, correct. Here 5 6, sum is 7, sum is 8 9 10, 6 7 8 9 10, here 11, correct. 5 plus 6 is 11. Now last one 6 1 7 8 9 10 11 and 12, correct. So what are the numbers random variable is taking? Random variable taking numbers. What are the numbers? 1 is there, sorry, not 1, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is there, 8 is there, 9 is there, 10 is there, 11 is there, and 12 is there. Maximum 12. You can see here, that is 12 is the maximum. Minimum is starting with the number 2, correct? Number 2 to 12, all the numbers random variable x taking, correct? So I can write here, x means sum of the numbers means x takes values. What are the values? X take values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, x values. Now what is our first question? Find the values of x. This is what values of x. What are the values of x we got? 2, 3, 4, 5, 6 up to 12 we are getting. Okay, so first part of the question is over. Now we will go to the second part of the question. What is the second part? Obtained the probability distribution of x. Probability distribution we need to calculate, correct? So probability distribution. How to calculate probability distribution? We need to create that table, correct? What are the rows in the table? First we need to calculate x. X we need to write in the first row. Second row we need to write probability of x. Okay. What are the x values here? We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hope you understood this one. Now I am calculating the probabilities now. Okay. So these numbers you know, x0, x1, x2. Okay. Sorry, not starting x0, x1, x2. We can continue up to the last that one, whatever values we are getting. Okay. Here. Now we need to calculate the probability. So x1, x2, I can write x3, x4, x5, x6, 7, 8, 9, 10, 11, correct? Because starting from 2. So we can get it 11 numbers, random variable. Now probability. X equal to 2 coming. What is the probability? We can check first. Probability of x equal to 2. That means the number 2 coming how many times here? The question. This sample space. Number 2 coming. How many times we can check here? See, 2 coming here. 1. Because adding is 2. What is the next to 2? There is no other 2. Correct? Only one time. So what is the probability of that one? Number of favorable outcome is 1. Divided by total number of elements in the sample space is what? 36. Correct? So we can write, we can write here 1 over 36. Hope you understood. Now the second one, okay, x equal to 3. How many times are coming? You can check it. X equal to 3. Here 1 is there. X equal to 3. Now where is other? Here 1. Correct? 2 times are coming. So we can write 2 divided by 36. Now number 4, you can see number 4 we are coming. Here number 4 is there. Here also number 4 is there. Here also number 4 is there. Correct? So how many times it is coming? 3. So 3 favorable outcome divided by total number of outcome 36. Now same number 5. Number 5 we can check. Here 1 is there. Okay, and here 2. And here it is 3. Here it is 4. So how many outcomes are there? Favorable 4 divided by total number of outcome 36. Correct? Adding sum is 4. That is the meaning. Sum number 5 how many times? Okay, 4 times. So same like when the table, if you are checking all the numbers, you will get like this the table. You can check one by one. 5, 6 means 5 times it will come. 5 divided by 36. 7 will come 6 times. 6 divided by 36. And 8 will come 5 times. 5 divided by 36. And 9 will come 4 times. 4 divided by 36. 10 is coming 3 times 3 divided by 36, and 11 is 2 times 2 divided by 36, 12 only one time 1 divided by 36. So this is the second part of our question. Write the probability distribution of x. That means x together with its probability. Okay, so that is the idea here. Now third question we are going. Find the expected value, variance and standard deviation of the random variable x. Okay, so before going to start that one, if you write x square here, you can do easily. Create one x square here. Okay, x square table here. That means x number square. For example, 2 number square 4, 3 number square 9, correct? 4 number 16, 5 number 25. Like all these we need to write here. Okay, 6 number 36, 7 49, 8 64, 9 81, correct? 10 means it is 100. Now 11 means 121, correct? Then 12 means 144. So just to create x square also together with that probability distribution. Now we can answer the third part of the question. Okay, first we are doing expectation of x equal to, expectation of x or mu equal to, what was the rule we studied? X1 multiply probability of x1, x2 multiply probability of x2 up to last, correct? So we can write the rule like x1 multiply probability of x1 plus x2 multiply probability of x2. I am not writing all the term, plus up to plus last one. What is the last one? x11, correct? x11 multiply probability of x11. Okay, so you can check the calculator one by one. For example, x1 means 2, multiply probability of x1 1 by 36, plus x2 3, multiply 2 divided by 36 probability, plus like this going, enter in calculator all the term. Last one 12 multiply 1 divided by 36. You will get the answer equal to 252 divided by 36. You can write the point number also, no problem. 252 divided by 36. Hope you understood the mean. Now I am going to the expectation of x square. Expectation of x square. For calculating variance, we needed expectation of x square. What is the rule for expectation of x square? x1 square multiply probability of x1 plus x2 square multiply probability of x2 plus like that it is continuing, plus x11 square multiply probability of x11, correct? Apply the number. x1 square means what was the number? 4, multiply probability of x1 means 1 over 36, probability same, x number square, plus x2 means 9, probability means 2 divided by 36, plus enter up to the last to the calculator. Last one was, what was the number? 144, multiply probability value 1 by 36. So you will get the answer equal to 329 divided by 6. You can check the calculator, is it correct or not? Then we are going to the calculate variance of x, correct? Variance of x equal to sigma square. That means what is the rule? We are writing expectation of x square minus expectation of x, that means mean, whole square. What is expectation of x square? We got 329 divided by 6 minus expectation of x, what we got, that is 252 divided by 36. It is almost 7, it is same only 7. Okay, so we will get 252 divided by 36 square or 7 square, correct? Check the number, you will get 35 divided by 6. 35 divided by 6. So that is the variance of x. Now, what is the next part of the question? Find the expected value we calculated, variance we calculated, standard deviation also we need to check this one. So, standard deviation means sigma. What is the rule? Root of the variance, correct? Variance of x, whatever answer, take the root of that number. So, root of 35 divided by 6. You will get approximately number 2.41522945, like approximately 2.4. Okay, this is the standard deviation of the random variable x. Hope you understood this one. Okay, now let me go to the sixth question. Question number 6. Let two fair dice are thrown. Here also two dice are thrown. Find the variance of the random variable. We need to calculate the variance of the random variable that assign maximum number occurs on the pair of dice. Maximum number, that is the random variable x here. Maximum number occurs. Okay. So a dice is throwing two fair dice are thrown. So sample space, whatever we wrote just before, the same, correct? What are the sample space? 1 will be there, 1 2, 1 3, correct, 1 4, okay, then 1 5, 1 6, like that, 1 5, 1 6, then we have 2 1, 2 2, I am writing again, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 5, 4 6, then 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, correct? Then 6 1, 2, 3, 4, 5, 6. Okay. So how many elements are there in sample space? Equal to 36. Correct? 36 elements. Now, what is the random variable here defined? Maximum number occurs in each pair of the dices. Okay, maximum number. So I can write here x equal to the maximum number. Okay, so what are the maximum number? You can see each pair check what is the maximum number there. Okay, for example 1 1, both number are same, so maximum number is 1 itself. 1 2, which is the maximum number, bigger number, correct, 2. 1 3, 3. 1 4, which is the maximum, 4. 1 5, 5 is the maximum. 1 6, 6 is the maximum. 2 1 2, 2 2, 2 is the maximum. 2 3, 3 is the maximum. 2 4, 4 is the maximum. 2 5, 5, and 2 6, 6. Okay, 3 1, 3 is the maximum. 3 2, 3, 3 3, 3, and 3 4, 4. Here it is 5, 6. Here 4, 4, 4. Here also 4. Here 5. Here 6. Here 5. Here 5. 5. 5. And here 5. 6. And here 6 again. 6, maximum number 6. Here also maximum number 6. Maximum number 6. And here also 6. Correct? So what are the values possible here? 1 possible, 2 possible, 3 possible, 4 possible, 5 possible, 6. Maximum 6 only getting. Correct? So I am writing the random variable value. So x takes values. What are the values coming? Values are 1, 2, 3, 4, 5 and 6. Correct? You can see 1, 2, 3, 4 up to 6 we are getting 1, 2, 3, 4, 5 and 6. Now just to create the probability distribution for calculating the variance, we need to create probability distribution here. Okay, x and probability of x. So what are the x number here? Only 1, 2, 3, 4, 5 and 6. 6 numbers get like this. Okay, now write the corresponding probabilities. How we are writing probability? 1, first 1 coming, how many times we can check it? Here 1 is there, any other one it is no, so only one time. So what is the probability? 1 divided by total number of elements in the sample space 36. 1 coming only one time divided by total number of elements in the sample space 36. Now 2, number 2 coming, how many times you can check? Here 1, here 2, here 3, any other? No, 3 only, 3 times. So 3 divided by 36. Now same like number 3, if you are checking 5 times it is coming, 5 divided by 36. 4 when you are checking 7 times it is coming, 7 divided by 36. 5 is coming 9 times, 9 divided by 36. 6 coming 11 times, so 11 divided by 36. Okay. Now we can go to the expectation and mean, variance, standard deviation. Before that we can create x square also here better for calculation in this probability distribution together with x square also. X square, x number square, 1 number square 1, 2 number square 4, 3 number square 9, 4 number 16, 5 square 25, 6 square 36. Okay. Now we are going to answer the first question, that means expectation of x, mean. Here the question asked only the variance, but variance if you want to calculate, you need to calculate first mean, correct? Mean calculation after that only variance can do. So we can see what is the expectation of x equal to, what was the rule? Here how many variables are there? x1, x2, x3, x4, x5, x6, correct? 6 numbers are there. So x1 multiply probability of x1 plus x2 multiply probability of x2 plus like that last up to plus x6 multiply probability of x6, correct, equal to. Now calculate from here. 1 multiply probability means 1 over 36. So 1 multiply 1 over 36 plus second one you can write the numbers, 2 multiply 3 divided by 36 plus like that you can enter all in calculator. I am writing here all the last term here, 6 multiply 11 divided by 36. So when you are checking your answer you will get 4.47 approximately 4.47 we will get it. Now so mean we got. Now we write what is the expectation of x square. Square, what is the rule? x1 square multiply probability of x1 plus x2 square multiply probability of x2 plus up to last plus x6 square multiply probability of x6, correct? What is x1 square? We got 1. 1 square is 1 multiply probability of x1 1 over 36 plus x2 square is 4 multiply 3 over 36 plus last I am writing plus 6 square is 36 multiply 11 divided by 36. So when we are calculating you will get approximately 21.97. Okay. Now from this we can calculate what is the variance of x equal, variance of x means sigma square, equal to what is the rule? Expectation of x square minus expectation of x whole square. Apply the number. What is expectation of x square? 21.97 minus what is expectation of x? 4.47 approximately I am writing square. So approximately you will get the number 1.9891 approximately. Okay, so this is the variance of x. Now if you want standard deviation, what we do, root of the variance we can take, root of the variance of x. You can check what number that getting, root of 1.9891 approximately. You can check by calculator what answer getting. Hope you understood this question. Now one more question we are doing, the last question. You can see Ahmad tossed 2 fair coins. Okay, he wins OMR 6, Omani Real 6 if 2 heads occur. If 2 fair coins are tossing, so 2 heads are, both coins are tossing, showing head means he will get 6 real, and 5 real he is getting if 1 head showing, one of the coin showing head means he will get 5 real. Okay, and 1 real if he is getting no head occur, both coin not showing head means he will get 1 real. So this is the question. So find the expected winning for the Ahmad. Okay, find the expected winning for the Ahmad. This is the question we need to do here. Okay, so think about it. Ahmad tossed 2 fair coins. 2 coins are tossing. So what will be the sample space? 2 coins are tossing means either head will come, or head tail will come, or tail head will come, or tail will come. Correct? That means how many elements are there in sample space? Number of elements of S equal to 4. Okay, now you can see, so Ahmad winning percentage is based on the number of head occurs. Correct? Number of head occurs. So we can write here in the random variable x. X means, what is the meaning? Ahmad winning based on the occurring of head. Correct? So I can just write Ahmad winning based on occurring head. Correct? Occurring head. For example, see, if both coin are showing head, okay, what is the winning amount Ahmad getting? He will get 6 real. Correct? 6 Omani real. If one of the one head occur, that means either head tail coming or tail head coming, because 2 coins are there. First coin showing head, second tail, or first tail, second head, like this. If these 2 are getting means he will get how much? 5 Omani real. Correct? And if there is no head, that means both coins showing tail, what amount he will get? 1 real we will get it. Correct? He will get it 1 real. So what are the values the random variable x taking? X means, that means x of head means 6. X of head tail or tail head means it is equal to 5. Correct? 5 real. So we can write x of head tail means 5. X of tail head also 5. Then x of tail means equal to 1 real. So I can write here x takes values either 6 or 5 or 1. Correct? X 5, 6, 5 and 1. 6 real, 5 real and 1 real. Now I am just creating the probability distribution here. Okay, I can just create the probability distribution here. So first row we write the random variable, second row we write the probability of x. Okay, probability of x. So what are the x numbers? We can write 6 real or 5 real or 1 real. Correct? So what are the probability we write? Probabilities we can write. For example, x equal to 6. 6 real means what is the outcome? Only head. Correct? One outcome. How many total outcomes there in sample space? 4. So what is the probability? 1 over 4. Correct? Head only 6 real. So this means 0.25. Now 5. Getting 5 means what are the outcome? Either head tail or tail head. So how many outcomes? 2. How many total outcomes? 4. So 2 by 4 means what is the number? 0.5. Now 1 real means what is the outcome? Tile and tile. So how many outcome? 1 divided by total outcome 4. So 0.25, correct? 0.25. This is the probability distribution representing that random variable. Now for doing question, we can write the x square value also in that table, x square, because the question is expected value only, sorry, so no need x square, here only x square, we need to do only the variance, so no need x square, x and probability of x, okay, because our question is find the expected winning Ahmad, expected value, winning for Ahmad means x, so expected value of x, okay, you can see that word expectation, expected winning Ahmad, so expected value of x, okay, so we can calculate this one, expectation of x equal, that means mean, equal to mu, equal to, what is the rule we studied? Here we have x1, x2, x3, 3 values are the random variable x. So what is the rule we are writing? x1 multiply probability of x1 plus x2 multiply probability of x2 plus x3 multiply probability of x3. Just apply the number. x1 means 6 real, probability 0.25 plus x2 means 5 real, probability means 0.5, x3 means 1 real, multiply probability means 0.25. So what answer we will get, you can check, 4.25, okay, 4.25 is the expected winning for Ahmad, okay, expected winning for Ahmad means 4.25, 4 real 25 paisa. Hope you understood this idea, this module. So this module mainly we are discussed these three, as you know, these rules, whatever I shown before slides, we can show that one again. This one. So whatever we discussed here, expectation of x we are studied, what is the rule, expectation of x square how to calculate it we are studied, variance of x how to calculate it we are studied, standard deviation how to calculate, we studied that one, okay. So this is the main idea in 5.4 section, and moreover probability distribution, okay, probability distribution, okay, how to check that is probability distribution or not, this is main idea, probability and random variable together we are writing means probability distribution. So I hope you understood all the question whatever we discussed in this section, okay. You can practice more question if you want. So thank you for watching this recorded class. Thank you.